So, let's look at multiplying multiples of 10 by single digit numbers. Here's our first example, 50 multiplied by 3. Now we can look at this in a few ways. One way is to say that we've got 50 3 times. That's 50 one time, 50 two times, 50 three times. And we could work out the repeated addition, but in maths it's all about looking for shortcuts in efficient ways. So let's have a look at how we can solve this using what we know about multiplication. So let's have a look at the 50. Isn't 50 really just 10 times 5? So therefore, isn't 50 times 3 just 10 times 5 times 3? What we see here is we've got two expressions that are equivalent. 50 times 3 is the same as 10 times 5 times 3. So what we can do is look for a familiar multiplication fact, and I can see one here, 5 times 3. And if we solve that and multiply that by the 10, then we've worked out 50 times 3. We've just broken it down. So let's do it. 10 times, well, what's 5 times 3? 5 times 3 is 15. So all we've got to do now is use what we know about multiplying by 10 to work out 10 times 15. When we multiply by 10, all we do is add a 0. Now, to understand that fully, please go and watch the multiplying by 10, 100, and 1000 video. That will talk about why we just add a 0. But we should know by now it's automatic. When we multiply by 10, we add a 0. So 10 times 15 is 150. So therefore, 50 times 3 gives a product of 150. Good, let's try another one. This time we'll go 70 times 4. 70 times 4. So we look at the 70 and we can break it down. So 70 is 10 times 7. So 70 times 4 would be the same as saying 10 times 7 times 4. And if we work out 7 times 4 and multiply that product by 10, then we've got our answer. So let's do it. So 7 times 4 is 28. And we're multiplying by 10, so we simply take our number, 28, and add a 0. So we've got 10 times 28 is 280. So therefore, 70 times 4 is 280. So you might start noticing a little bit of a trend here. What we can see is that essentially we're ignoring the 0 and we're doing 7 times 4, and then we're adding that 0 back in at the end. Let's do another one. 20 times 9. This time we'll just do the shortcut way. So we'll ignore the 0 and we'll look at 2 times 9. So 2 times 9 is 18, and then we add the 0 on. So we've got 20 times 9 is 180. Another one. Let's do 60 times 5. Okay, so we ignore the 0 and we look at 6 times 5. Well, 6 times 5 is 30. And then we add that 0 back on. So 300. Okay, let's look at now what happens when we're multiplying by 100, or a multiple of 100. So, for example, what if we had 200 times 3? Well, again, let's break it down and then we'll look at the shortcut. So, breaking down that 200, Well, what do we know about 200? What's it made up of? So 200 is, well, isn't that just 2 times 10 times 10? Or another way we could write it is 10 times 10, which is 100, times 2. Okay? So, therefore, 10 times 10 times 2 is 200, and if we multiply that by 3, then we'll have the same answer as 200 times 3. So essentially, this expression is equivalent to this expression. So let's do it. Let's do 2 times 3 first. 2 times 3. So 2 times 3 is 6. And then we've got that 10 times 10 we'll bring down. So we've got 10 times 10 times 6. So let's do that 10 times 6 next. So 10 times 6 is 60. And then we bring down the 10. And now we do 10 times 60. And 10 times 60 equals 600. It's just 60 and adding 1 0 using what we know about multiplying by 10. So therefore, 200 times 3 is 600. So do you notice another little pattern? We've got 2 zeros here, and we've got 2 zeros here. If we work out the basic fact, ignoring those zeros, and we do 2 times 3, which equals 6, and then we add those zeros at the end, and we've got our result. So we can look for shortcuts like that. Let's do another one.